Okay, so 10 minutes have been passed. We are starting today's lecture. A very good evening to everyone and welcome back. Today we are on the sixth day of this Future Skills Development course that is initiated by the Tech Abul Kalam Azad University of Technology, West Bengal. Myself, along with Komulika Bhattacharya, the faculty from Department of IT, is taking these lectures on the topic Introduction to Artificial Intelligence and Machine Learning. Today, on the sixth day, we'll be talking about how to implement neural network architectures for the e-learning of dance videos. On the last class, you have been taught the artificial neural networks and how the training can be done by your Komulika map. So today our topic is e-learning for dance videos using neural architectures. So now I'll be starting the screen sharing. Okay, so just a second. Okay, I think the screen is visible to everyone. Anyone from the audience, anyone can just type it in the chat box?
Yes, ma'am, it is visible.
Okay, fine. So this is the paper that
Yes, ma'am, it is visible, ma'am.
Today. Yeah, I got it. Okay, so today we'll be discussing about this particular paper where the name is Human Skeleton Matching for E-Learning of Dance using a Probabilistic Neural Network. So that is PNN, that is a Probabilistic Neural Network, is a type of neural network. On the last class, you must have learned about what is the neural network and how that can be trained. So one particular type of the neural network, that is the probabilistic neural network, that we are going to discuss today. So this paper is being published by the IEEE in the conference of the International Joint Conference on Neural Networks, IGCNN. This is one of the flagship conference by the IEEE. The conference was organized during 24 to 29 July 2016, and the conference location was Vancouver, Canada. So there this paper is being published, and these are all the authors from the paper. So if you can just go to all the authors, then you can just check that along with me, we have in the authors list Dr. Rimita Lahiri, Professor Amit Kona, Bonnie, and Dr. So this is basically a paper that's from the India, USA, and UK. From these three regions, we have participated for this particular research work. So it's a collaborative research work among three different universities. This is one of the work during my PhD days. So if we are coming to this particular paper, so this is the paper where we are using human skeleton, and that human skeleton matching is done for the dance videos for the purpose of e-learning of that particular dance, and the methodology, that is artificial intelligence tool that is used, that is the probabilistic neural network, that is using PNA. E-learning of dance videos have been achieved, and how that is being done by the human skeleton matching. So what is that matching mean? That is, there will be the training data set. Some human skeletons will be present for certain types of dances. For the similar type or the same type of dances, there will be the skeletons from the testing data set as well. So that is basically the magic that is being achieved. So for this particular paper, these are the contents, and I'm not just reading out the contents, that we'll be discussing each of them. So that is the first will be the introduction. So introduction is what? That is why we are doing this. That we need to clarify beforehand, right? So in the introduction, so it's going to, this particular work is going to provide effective ways of communication, as e-learning of dance is going to give us a cost efficiency, time complexity, and portability as well. So in this COVID-19 pandemic scenario, as you are all learning your subjects, whatever be the subject, whether you have that subject, machine learning, or any type of mathematics or any type of subject you are studying from your home. So you know very well what is the efficacy of e-learning. Right now, you do not need to travel to any place and you can learn in the comfort of your own home. Traveling to one place that involves cost, that involves the time as well. So these are the issues and not associated with all of us currently. So these are the efficacy of e-learning. So these efficacies are also lies there for the when someone tries to learn the dance by the e-learning format. So whenever someone is learning anything from the e-learning media, these are the effective or these are the advantages of doing that. And how they are doing that is dance is a very much attractive way of attractive way of displaying one's body gesture. That is how the communication is done. That is the body by the body language. Communication is done can be done between two dancers or from the dancers to the audience. That is, different emotions can be displayed by the body gestures that are portrayed in the dance form. And what does the term gesture mean? That is, gesture signifies different postures that the human structure embodies while displaying various actions as well as emotion. And dance is chosen as a preferred alternative as it incorporates both facial expressions. You might have seen different excellent facial expressions by different dancers and the body movements, which collectively, that is the facial expressions as well as the body movement, both at the same time enhances the ability of a user that means the dancer, to convey his or her emotions basically. So by the dance, if that is portrayed in a good way, good form, then the human's body language can be by that body language that has been displayed in the dance, one can understand what's the emotions the dancer is portraying. That can be so any of the research work that any of you are currently doing, before starting that research work, you need to know that what has been done earlier. So that is the literature survey or the literature that are already available. Uh, Presently, you need to study them and you need to go for a comparative one. You have to comparatively justify that your research work is much more potent than the others. So that is for the literature survey domain. In the paper, that is a published paper in the conference proceeding, you can find there are more than there are only three are given in this particular slide, but there are other literatures also there. If you study that particular conference proceeding, you can find those. But for the simplified way, you can have these particular three literatures. In all of the researchers, basically, one is from our particular research group as well, that is the second. So here we have done the work and the other researchers also done the work, but what the lacks is that one particular lacuna is that they are not involving much complex body gestures that are portrayed in the dance. So in this particular research work, we have taken the complicated dance forms, and the complicated dance forms are recognized by our proposed research. This is one particular lacuna have another format, that the accuracy. So we have much more better accuracy than the already present research work. So these are the two that we are trying to overcome. So for that purpose, this is our proposed work. So what's the proposed work? That is, different dance forms will be displayed, and from the dance form, skeletons will be formed. Okay, so now the question arises, how we are going to get the skeleton. So to form the skeleton from the dance gesture, one way is doing the image processing. You can do the image processing and can obtain the skeletonized versions from each of the human body gesture. So that has a limitations due to the lighting condition or due to the different types of neighboring objects of the dancer. The accuracy of recognizing the skeletons from the body gestures can be very poor. So what we have done over here, we have used Microsoft Kinect sensor. Microsoft Kinect sensor that is explained in the last lecture as well. Today we'll be repeating that. If anyone has misses that, wants to know much more in a better way how dance can be portrayed. So for that we have this thing. So I'll be sharing this particular video. This particular teacher recognition has been done under the guidance of Professor Amit Kumar of Dadapur University in the control system lab under his guidance, obviously. And this particular video will be demonstrated by Dr. Reshma Kaur. So you can just look at this particular video, and after completion of the video, when the sensor will be uh, explained while recognizing the body gestures of the dancer, they will again go for the PPT and will continue our particular lecture on for that particular conference paper. So right now we are focusing on how the skeletons can be recognized while someone is portraying a particular task. So just look at it.
I have the Kinect box. This of happiness through her dance gestures.
So here you can just find. So this is already explained in the last class. What is that? This is from Kinect sensor. You can have three different outputs basically. This is the RGB camera view. That is the normal camera. How we are capturing that is captured by the Kinect sensor. So that is the RGB camera view. This is the depth data, right? Depth is what? From the Kinect you have an IR emitter and an IR receiver. So IR emits something, IR, that is the IR emitted, and that IR is reflected back to Kinect sensor. By that we can find the time of flight of the IR, and if we can find the time of flight, then we can find that how much far that particular object is from the Kinect sensor. So that is the depth view is there. So that is X and Y coordinate that is being calculated from here, and the Z coordinate is calculated from here. And you already know that is the Microsoft Kinect Xbox 360. It can record 20 body joint coordinates in 3-dimensional space. So for each of the 20 body joint coordinate, we are going to have X, Y, and Z coordinate. That is going to give us the skeletonized form. So that is, this is the skeletonized form. After combining the depth view and the camera view, this skeletonized form has been created. And here you have 20 body joint coordinate, and each coordinate has 3-dimensional value, that is the X, Y, and Z coordinate values it has. And for this Kinect, this is the sampling rate, that is the 20 frames per second. This is the sampling rate by which Kinect is capturing the data. So again, we are moving to the particular video.
As you can see, the Kinect easily captures the depth and XY information, and these information of the depth and the XY coordinates are stored in a file concurrently as they are recorded.
So from the video, you can understand that is the Kinect can able to capture different complex body joints, and that is how the skeleton is formed. After the skeleton is formed, we have constructed 5 planes, and from the 5 planes, features are extracted. And the features, that is, there are 4 features are going to be extracted. So that is 4 acute angles and 4 normal distance. That is, sorry, 8 features will be extracted. In 4 in the terms of acute angles and 4 are the normal distances. From these 8 features, probabilistic neural networks will be trained, and for the testing purpose that will be matched to identify which particular emotions is being depicted by the dancer. That is the overall of the proposed work. So this is the RGB camera view, that is RGB image, and this is that is the dancer is performing in front of the Kinect sensor, and this is the Kinect sensor already explained. That is the RGB sensor is there, that is the IR emitter and IR receiver basically is there. And just a second, arrow is pointed wrong. Just a second, arrow will be over here. how this arrow is. Okay, so this is the IR sensor basically. Okay, and this is the kinect sensor. And after that, processing this the dancer's information, that is the skeletonized image is given over here. And in this skeletonized image, 20 body joints are present. This is how skeleton is formed using Microsoft Kinect sensor. Now here 5 planes are being constructed. That is, one is that is PLA, that is from plane is being constructed after taking the joint information. Which joints? These are the 3 joints that has been marked in the green bold color. From the 3 joint, this plane, that is the left arm plane, this is the right arm plane is constructed by the joints over here. So this is basically this particular joint, this particular joint, and this particular joint. From the right arm, these are being constructed one particular plane. LL means that is the left leg. These are the joints, that is the knee, ankle, and foot. These joints are considered over here. Similarly, for the right leg, TRL is constructed. And here, this is the reference plane. Okay, so that is the T reference is constructed. So basically 5 planes are constructed. And this is the spine joint. So white spine that you can understand over here. So features need to be extracted, and features will have 8 features values we are going to have for each of the frame. So first 4 features are the acute angles. So that is the acute angle between the reference plane and the left arm plane. Then the acute angle between the reference plane and the right arm plane. Then the acute angle between the reference plane and the left leg plane, and the acute angle between the reference plane and the right leg plane. So these are the 4 acute angles. So to have the acute angles, we have calculated the reference plane. Now, to get the normal distance for this PLA, PRA, PLL, and PRL, we need one particular point from where normal will be drawn on these 4 planes. So these is the 4 normal distances are taken from the spine joint. Normals have been placed on 4 planes, and the normal distance that belongs to the 4 features again. So that is, we have now 8 features, 4 in terms of acute angles and 4 in terms of normal distance. This is being calculated for each of the frames. Now, this is the architecture of the probabilistic neural network. We are not going into the much details of that, as to explain this itself takes around 1 hour. So just a basic we are going to give. So what's the you have learned in the last in neural network has basically input layer, output layer, hidden layer. Okay. So that is input layer, input vector is given. That is the feature space basically that is going to be given. After the feature space, each features will have, that is as input now, have certain weight matrix. So this is how weight matrix is being calculated by the PNN. Now these are the bias term. We need the bias. So this is going to the radial basis function. So this is now the radial basis layer. After that, layer weight matrix is calculated over here, and then the output is being generated. So this is the competitive layer. So that is probabilistic neural network has 3 layers, basically named as input layer, radial basis layer, and competitive layer. And these are the equations by which you can calculate each of the parameters. So by each of the equations has been specified, and what are the values of f? F means the number of frames. That is how many, for how much duration you are taking the data. So you have already know that for Kinect you can know the sampling rate. So if you know the one particular video is taken for 3 seconds of duration, and sampling rate is suppose 20 frames per second. So 20 into 30, that is 600 frames will be there. So what's the value of f? That is 600. For each of the frames, how many features has been calculated? 8 features. So that is capital R, that is number of features, that will be 8. Number of samples, how many sampling is done, that is the Q. Number of subjects, that is we have taken the data from suppose 8 dancers, 10 dancers, 60 dancers. So number of subject is that M value. And number of gestures, that is how many gestures is being considered, that is the E value. If you know all of the parameters values, you can just feed into these particular equations, and then probabilistic neural network will be trained. So this is the overview of the PNN. Now for this particular work, we have considered 5 emotional dance stages, dance gestures. So that is the anger for each of the dance forms. For specific 3 frames data has been given, as it's not possible to give all the frames data. So just frame number 20, frame number 60, and frame number 100. The data have been given for 5 different emotional gestures related to 5 different types of dances. That is the anger, fear, happiness, sadness, and relaxation. And these are the data have been given for the 25th sub. That is that we have taken the data for many subjects, and these are the subject with the 25th number subject. Now, as it's a classification problem, so any type of classification you can have a confusion matrix. For the confusion matrix, that is confusion matrix going to give a tabular form about the actual class and the predicted class. That is what's the actual class and where it is the predicted class. So if your actual class is anger, your predicted class should be anger. So that is this particular value should be as high as possible. So, and if this particular value is very high, that is close to 100, that is it's a percentage ratio. So if this value is in the 100, near to the 100, so the summation of all the 4 other values will be very less. So as if the actual class is anger, our predicted class should not be either fear or happiness or relaxation or sadness. It should not be among the 4. So that is, we want this particular cell value to be as much closer as 100. Similarly, if your actual class is fear, your predicted class should also be fear. So these particular cell values should be as much high as possible. If it's happiness, result should be happiness. For relaxation, this particular cell, and for sadness, this particular cell. So that is, if we can go along the diagonal way, these values should be closer to 100. That is, this diagonal value should be as much high as possible. So if these values are close to 100, so that means you are getting higher accuracy, and all the other values should be as low as possible. And the summation of these 5 values should be 100. Okay, so that's the confusion matrix. So confusion matrix is basically to solve our confusion about the actual class and the predicted class level. Okay, so in the last few classes we have already discussed, that is, whenever we are proposing any type of algorithm, we need to compare that algorithm with all others available algorithm that has been worked by those algorithms that has been worked up by the earlier researchers. So for this particular architecture as well, that is the PNN, probabilistic neural network, we have replaced that PNN with BPNN, that is back propagation neural network, RNN, recurrent neural network, FFNN, that is feed forward neural network, ECBT, that is ensemble classifier base tree, that is the base was tree, LSVM, linear SVM, RBF SVM, radial basis function SVM, support vector matching, and KNN, that is K nearest neighbor. And you can find over here, that is for the PNN, these values are highest one. Okay, that is for the what are the matrices that we have considered, that is the accuracy, precision, sensitivity, and specificity. And this particular column for the t-test, that is statistical test to justify our claim. So these level, we can easily justify that our work is much more better than the already available. So those were the uh, four matrices. Now, in the last class, we have seen that if one accuracy is high, but your time complexity is also high, then the overall system betterment falls down. So you need have a high accuracy as well as lowest computational complexity. That is, it should have the low amount of time. Whenever we are going to implement the system in the real life, suppose one novice dancer is trying to learn the dance, so he or she has performed the dance. Now that person cannot wait for 2-3 minutes to get the result. They need the result as much fast as possible. So we need the result in a few milliseconds. If that time is very high, so then after if the novice dancer is learning very complex dance gesture, very high amount of time, then total time was also is going to be increased exponentially. That we do not need. So we need a system where the time complexity will also become very low. So these are the computational complexity values, different competitive algorithms. So these are the algorithms that are these particular algorithms. For each of the algorithms, timing complexity values are also being calculated, and this is a comparative study of that. Okay, now you can find that is for LSB, BFSBM, and KNN, the values are much lower than PNN. Why not these three? As for these three cases, the accuracy values are very low. So that is the accuracy in the 91.7%. Here it is 72.6%. We cannot deal with so much lower accuracy. Okay, it can be a few millisecond difference, but we need higher accuracy as well. So this is the scenario why PNN is the best choice for this particular architecture. So if we just go for the conclusion, that is this particular architecture provides a cost-effective and easy of use of way of e-learning of dance. Maximum accuracy is obtained at 91.7%, and the feature extraction strategy, that is the accurate angle and the normal distance, is very efficient and has little scope of error. Now it's very easy to install this type of algorithm, this type of architecture in the real life, as it means only the kinet sensor. By that, it can easily be implemented. And there is ample scope for applying image processing with gesture recognition strategy. That is, in the future, we have tried to implement along with the body gesture. We have tried to recognize the facial expressions at the same time. That is, while the dancer is performing, not only his or her body gesture, as well as their facial expressions are also being recognized, such that suppose it's a very intricate Indian classical dance form. There we have very significant facial expressions, as well as the body gestures are very much interesting. So that is, if we can recognize both of them at the same time, so our e-learning application will be much more effective. So this is the conclusion we can make, concludatory remarks. For this particular research work, which is being supported by the UGC, that is University Grants Commission India, in the excellence program of phase 2 in the cognitive science in the Jadavpur University, as well as Dr. Banerjee has, for this particular research work, has been provided a fellowship by the NSF grant IIS, and this is the number for that. So we need to acknowledge them for giving us the fund to work on this research work. So these are the few prominent references that you can go for it. So now we are going to check okay, so one particular question is that if you have any other question, you can just type it in the chat box. One particular question we have, that is why not CNN? Yeah, we can use CNN, but CNN time complexity is higher. If we can achieve a reasonable accuracy, that is of 91.7% by just applying CNN, then why to go for much more complex? We can always increase the complexity increase the complexity of the system, it might give us better result. If we use a CNN, we might get, we haven't applied, or we might get accuracy of suppose 92 or 93%. But just to have 1% increase in the accuracy, it's not efficient to use CNN. This is one particular answer. Apart from that, this particular work has been carried out in the 2016. So it's 5 years down before that. So in 5 years previous to that, CNN was not that much popular in India, I can say. I don't know about the earlier things that we have the research papers in the dance, particular dance gesture domain that we have so far gone at that time of 2016 that uses only the BPNN. They haven't gone for the deep learning domain. So internationally at that time, deep learning was not that popular. So haven't. That's also another particular reason why we haven't applied CNN also. But I just have one particular doubt that if we use CNN, then also the accuracy can be increased around 1 to 2% as well. It's not like CNN will have that much accuracy. Like the dance is one particular thing is that when you are recognizing the dance gestures, it not like not other things. That is, if one particular dancer is portraying anger in one particular form, others can portray the anger in a different form. That will be very much related to the earlier dance, but the movement will be in such a fashion it might there can have certain dissimilarities among different dancers portraying one particular emotion thing. So nah, we haven't applied. You can do. You can apply CNN and you can check how much accuracy it comes. So you can that you can publish in a paper. So you can do it. Just check how much accuracy you are getting if you apply CNN. So if we have any other doubt, any other, then you just ask. You can type it in the chat box, or you can raise your hands. We can unmute you. Then, otherwise, we'll go for the implementation of this research work that is done in the Matlab. So if you have any doubt or any queries, you can just ask me. You can raise your hand or you can type it in the chat box. Otherwise, we'll move to the Matlab implementation of this particular research work. Okay, so I think there was no queries about, so we are moving for the Matlab implementation. So once again, I am sharing the screen. So in the Matlab implementation, so first what we need, first step was the feature extraction. So for the feature extraction, we need the finite data, that is 20 body joint coordinate in XYZ, that is 3-dimensional space of 20 body joint. For one particular data set, that is the sadness 3, that is for the third case, that open out here. So this is, you can just check how the data is being recorded by the Kinect sensor. That is, this is the X, the Y, and this is the Z coordinate values for each of the body joints. So this is the 20 body joint coordinate for one particular joint. After that, from 21, second frame data for 20 body joint coordinate is there. So this is the second frame data. This is the first frame data for 20 body joint coordinate, 3-dimensional space. This is the second frame. So this is how the data is there. From those data, I'm not going to the much details of that, as it will be very much details for you to learn that. For the data have been plotted by this scatter-tree plot, and then different joints have been joined using the plot function. These are the things that has been done. Then the feature extraction here is done. Okay, so in the feature extraction, then the feature extraction, that is the 4 in the acute angle between the reference plane and one particular P1 plane. That is the thing, that is this one particular, there is four acute angles and four, and these are the acute angles, things are there, and these are the normal distances that has been calculated. So that is 8 meters are calculated over here. So that is the particular feature is being calculated. So this is the feature extraction. After the feature extraction is done, we'll be moving to the neural network architecture, that is using probabilistic neural network. So before going for the probabilistic neural network, just have this particular neural network architecture for one particular randomly generated data set. So for here, a randomly generated data set has been created, and for this randomly generated data set, a neural network has been trained. So this is the randomly generated data sets are there. So from that data set, neural network, a random neural network is trained. It's not our actual neural network, but this neural network architecture has been created to just give you the explanation of the different layers. So just you can check over here is this is the radial dysfunction network being created over here. So what does a neural network need? It needs a input from those to the layers, and if this in the hidden layer there are two layers are there, so that these two layers are formed, and for each of the layers we need the weight matrix, we need the bias value, we need the activation function that we need. After that, moving to second hidden layer, here also we need the weight matrix, the bias, and the activation function. This is one particular activation function Gaussian, this is another particular activation function. After that, it is moving to the output layer to generate the output. In the MATLAB, how you can generate the confusion matrix? This is the plot confusion by which you can get the confusion matrix. So this is a randomly generated case. So this is the 0% or here the 100% case. So do not get confused by that. This is the randomly generated confusion matrix is there. That is the target class, that is the actual, and the output class, that is the predicted class. By that, confusion matrix is drawn. Okay, now we are moving to the actual PNN architecture, that is probabilistic. So for that probabilistic neural network, we need our train, that is, and the target, right? We are training the neural network agent. For that, there is a train and there is a target. So what's that? Just let me just run this particular thing. You can just check that is the neural network has been formed, and this is the probabilistic. This architecture, radial basis network, here it has been changed. So that is the probabilistic or PNN neural network. This is the how it looks like, and that how the train and tar look like. Just have a look to just give you the idea about that. So this is how the train matrix is look like. Okay, so this is the train is there, data for training purpose, and for each of the data it needs corresponding class levels need to be specified as it's a supervised architecture. So that is tar is there. So this is the tar data is there. Okay, and target is there. So different variables are created for this PNN architecture. And this is the timing complexity we have calculated, that is the elapsed time. So these are the scenarios. So if you just go over here, how the time is being calculated, that is given here. So that is neural network has been trained. So and also if we just plot the plane, so in the feature we have plotted, we have 5 different planes. One is the reference plane, and 4 planes were there, considering the body joints from the left arm, right arm, left leg, and right leg, right? So if you go over here, this is the plot plane. So these are the 5 different planes are there. If we just go over here, it might get confused. That is how many planes are there. So you can understand 1 plane, 2 planes, 3, 4, and 5. So I'm just trying to give you a better view how you can view 5 planes where you can easily understand. Planes are in such a fashion, it's not. So now you can, I hope you can understand. Here are the 3 planes, here are the 2 planes. These are the 5 planes that are being calculated for, and from each of the planes, the acute angle and the normal distance of the spine joint is taken as the meter. So these are the Matlab implementation that has been carried out for this particular. So if you have any doubt, you can type it in the chat box or you can raise your hand such that we can ask. We can unmute you and we can. So is there any doubt with anyone? Yeah, you can write it in the chat box. Okay, so we're waiting for 1 minute or 2 minutes to have your queries in the chat box, as well as you can raise your hand such that we can unmute you to have your doubt. So, okay, so it gives us immense pleasure that you have understood everything that has been discussed, as you don't have any doubt. Yeah, how to pre-process the data. Here, the pre-processing is done by the Kinet sensor itself. Kinet has taken the hurdle of doing the pre-processing. We are not doing anything. We are just getting the skeletonized form of the dance. What the subjects those are performed from the Kinet. The pre-processing, how the Kinet is doing the pre-processing, you can just check the Microsoft website. Everything has been given in the detailed how it is being done. From the RGB data, it has RGB data as well as the depth data. By that, it is being done. So we are not doing it, so that we are not explaining correctly. Any other queries? So every day we are getting queries from one particular person. None of you have, except none of you have any doubts or anything, right? You are, everyone is getting everything very clear. It's not a Siddhartha, for this particular project we have used MATLAB. So we haven't implemented in Python. We have used MATLAB, and how the implementation has been done, that has been shown to you. Any other queries? Okay. Any other? Or if you can raise your hand if you are not willing to type it in the chat box, we can unmute you. Okay. So I think no one has any doubt or any queries. So today we are going to have our first intermediate exam. So I'll be giving you the test link. Just take the test link from the chat box. Then you have to write all the questions are compulsory. You have to answer all the questions such that we can understand how much you are understanding the topic. I'm giving you the link in the chat box. Okay, so this is the link for that. This is the Google Doc form. Just copy it from the chat box. And all the questions are mandatory. You have to write answers for all of them. Just 5 MCQs are there. You have to very basic preliminary knowledge of ANN will be tested. Artificial neural network will be tested over here. So all of you got it. You just take the screenshot or
Dear students and dear participants, please note down the quiz link. That is a short test.
can I just give simplified quizzing to all of them? I cannot copy it from the chat box. That's the problem I'm facing. So yeah, okay, thank you. Okay, so take the screenshot Sir has given you, and it's very much compulsory for everyone. And the total time is 10 minutes. So within 10 minutes, you have to submit your answers. Then the link will be closed. As there are 5 MCQ questions, it's very simple. You need only 2-3 minutes. So it's okay. Take around 15 minutes. So it's 5 minutes left for say 8 p.m. So up to 7.